So now that you've learned about what a splitterator is, primarily focusing on the iterator part of a splitterator for sequential streams, let's take a look at how you could actually implement a splitterator in practice. And the particular splitterator we're going to look at here, of course, going back to our running example, is the one that's provided by the SimpleSearchStream case study that we've been using as a running example through many of the lessons up to this point. As always, you can get the source code for SimpleSearchStream at the link in the URL below in my GitHub repository. The SimpleSearchStream program only uses a sequential splitterator because it doesn't try to do anything more advanced. After all, it's the SimpleSearchStream case study, not the more powerful ones that we'll look at later. So there's really just one thread of control that's responsible for doing the splitting that we're talking about. The way in which this actually gets used internally to the program is there's a method called search for word. And what search for word is going to do is it's going to use the splitterator we're going to develop and show and walk through in order to find all instances of a given word, like in this case, the names of the musical notes, like do, re, mi, and so on. And it's going to try to find all the places that that occurs within some input string, which in this case, of course, will be the lyrics for the do, re, mi song. You can find this code in the wordsearcher.java file in the SimpleSearchStream program. Here's what it looks like under the hood. So we're going to create a new object called a search results object, and that's actually what's returned by the search for word method. And you can see how search results is passed a bunch of parameters. It's passed things like the word and the title and other stuff. And then it's also going to be passed essentially a list of result objects. And the result objects are going to keep track of the indices where the search word appeared in the input string, if they appeared at all. And the way we're going to come up with that list of result objects that keep track of the indices is we're going to use the word match splitterator, which is the focus of this lesson. So word match splitterator, as you can see here, is going to take the input string as one parameter and the word we're searching for as the other parameter, and it's going to then create a splitterator, and that splitterator is going to be passed to the stream support.stream method. So we're passing our own custom splitterator, not one of the ones that comes out of the box from the Java class library. We're going to pass in our own word match splitterator instance, and we're also going to pass in the false flag as the second parameter to stream support.stream. And that indicates make a sequential stream. So what we get back from this is going to be a sequential stream of result objects that keep track of where the matches occur. And then we're going to go ahead and collect that into a list. And when we collect it into a list, we'll end up with a list of these results, if there are any. In our case, there will be, because we're looking up the words in the lyrics to the song where the words appear. But more generally, you could be looking things up that wouldn't have a match, in which case you'd have an empty list. So that's essentially how this gets used, how the splitterator gets used. And you can see how we use it in conjunction with the stream support.stream factory method. All right, so let's go ahead and take a look at the word match splitterator class itself. So this class uses Java regular expressions to create a stream of search results result objects that keep track of the number of times a word appears in an input string, and more to the point, the index in the input string where the word match occurs, if there is a match. You can find this implementation in the word match splitterator.java file in my GitHub repository. Word match splitterator extends a helper class called abstract splitterator, which is part of the Splitterators class, and it's basically a nested class there. And abstract splitterator provides a bunch of predefined implementations of the splitterator interface, and the only thing you need to do if you want to extend Splitterator's abstract splitterator is implement the try advanced method. Here are some of the fields that are defined as part of the word match splitterator class. So the first field we have here is something that's a matcher, and a matcher is a class that's defined in the Java regular expression package, and it basically performs regular expression matching operations on a character sequence or a string. So we have a matcher, and then here is the constructor for word match splitterator, and you can see here how it's given a string, which is the input, and a string that's the word that we're looking for. And the first thing it does is it takes the word and it trims out any trailing or leading white space, and then it puts some regular expression tags at the beginning and end. And these tags basically say, only find matches that match exactly. In other words, don't look for substrings. Don't look for the word do in, don't look for the word do in an input word like does. That wouldn't match. So only look for things that are exact matches. Then what we do is we go ahead and we take that regular expression and we compile it into something called a pattern. And a pattern is basically a compiled regular expression. In this case, it takes the string that we had bounded with those tags, and then it also says ignore case. So the pattern.case insensitive flag that's passed into compile just says, don't distinguish between a capital D and a lowercase d if you're looking up do. What we then get back is a compiled pattern, which we then go ahead and associate with the input string using the matcher method. And the matcher method is a factory method that will make a matcher object, which we call mWordMatcher. So this matcher object will then use regular expressions to find anywhere that the word appears as a word, not as a substring, in the input that's passed to the word match splitterator. So the big picture here is we have a regular expression to look for matches in the input string. Now we can talk about the try advance method. This is the one that's the interesting method, really. Everything else was just setting things up to do what try advance is responsible for. So try advance is called by the Java Streams framework internally, automatically, when the splitting phase takes place. And what it does is it attempts to advance the splitterator by one word match. So what does that mean? Well, what it means is shown here when we take a look at how the code works. Notice that we are also passing in a consumer action, and that's what the framework does in order to be able to get the results back if there was indeed a match. So this is passed in internally by the Java Streams framework. The first thing that our try advance method does is it checks to see if there's a match left in the input string that we haven't already seen. So we call mWordMatcher.find. That goes and it says, is there a regular expression match for this pattern that we have not found yet in this input string, looking at it from beginning to end? And if the answer is no, there is not, find will return null. So if we negate that, that is true. So if we don't get a match, that's what this says. If there's no match, we return false. And that, of course, is an indication to the underlying streams framework that there's no match, stop advancing, take whatever you've done and use that as the stream. In contrast, if there was a match, then what we want to do is we want to go ahead and figure out where that match occurred. And the mWordMatcher.start method returns the index where the match occurred in the input. And we take that index and we wrap it up into a result object that keeps track of the index plus some other stuff, some other metadata about the match. And then we go ahead and we call the action.accept hook method. And that will take the result object and then allow it to be passed back to the streams framework so it can keep track of that as a result object that will be put into the stream that it's going to be creating. And in this case, we then return true, basically saying, hey, we got a match, and oh, by the way, it's worth calling try advance again to see if there's any more matches after we skip over the regular expression portion that we just did a match on. So you can see how try advance is taking advantage of Java regular expressions and the powerful pattern matching features built in to that class, to that package, in order to be able to find matches for these substrings, or sorry, for the words, not substrings, but for the words that happen to be in the input. And it's being passed back, and then the streams framework will use that to go ahead and create a stream, which in this case will be a sequential stream. So just to kind of reiterate what this looks like when all is said and done, the word match splitterator creates a splitterator, stream support.stream factory method, uses that splitterator, calls its try advance method, creates a stream of all the matches, which in this case will be a stream of result objects that keep track of the index where the match occurred in the string. And then we convert that into a list by using the toList factory method to make ourselves a list collector that can be collected and returned as a list. So that's basically how all the various pieces fit together. This is what it looks like, again, trying to give you a holistic right brain view of what's happening with all this code. The stream of words is then converted using the map intermediate operation into a stream of search results, where each search result keeps track of the list of indices where the word occurred in the string. And then, as you can see, if we were to follow a few more steps in the pipeline, we would get rid of anything that didn't have any matches at all and collect all those results up into a list of search result objects. So that's kind of the big picture of how it all fits together. So that's the end of our overview about how to apply Java Stream Splitterators. We will cover more advanced discussions about Splitterators later when we get to parallel streams. We'll look at the way in which the try-split method is used. So this is just focusing exclusively on sequential streams at this point. What we'll cover next time in our next lesson is we'll start talking about the way in which you can do the other end of the stream, which is the combining phase, by looking at all the different ways to make collectors in Java. And again, we'll focus at this point on the sequential versions, the so-called non-concurrent collectors, which oddly enough, as you'll see next time, can be used for both sequential and parallel streams, which may be a little hard to understand at first, but we'll cover it in great detail.